Good morning, everyone. This is Khwaja Ahmad, and today we are going to have an idea about production planning and control, forecasting, and computer integrated manufacturing. At the end of this session, most of us will be able to understand what is production planning and control, what are the why forecasting is being done, and what are the various methods of forecasting, what is automation, what is SIM, how the SIM evolved, and what are the various elements of SIM. Dear students, as you are well aware that production management and planning is one of the most important factor associated with the industries. Without managing the production and without planning the production, it is not feasible to achieve the required outputs with the minimum benefits which the company or which the management wants. So first we will try to understand what is production. H.A. Harding says that production is concerned with those process which convert the input into outputs. The input are various resources like raw material, men, machine, method, etc. And the outputs are goods and services. We must be able to understand this that production is nothing but converting raw material into some usable products. This can be achieved with the help of a process, and the process are various types of process available in the industries where different raw materials are being converted into usable components or usable products with the help of man, machine, and methods. Similarly, E.L. Brack said that the production is a process of effective planning and regulating the operations of that section of an enterprise which is responsible for the actual transformation of materials into finished products. Here, Brack said that planning is okay. If you are planning, then everyone plans. But he says that effective planning and then regulating the operations of that section is one of the important point and is the responsibility through which we can achieve good production. Similarly, yes, Buffa says production deals with decision making related to production processes so that the resulting goods or services are produced according to specifications in amounts and by the scheduled demand at minimum cost. So, production refers to the application of management principles to the production function in the factory. In other words, it involves application of planning, organizing, directing, and then controlling the process. Thus, production is the process of bringing together men, material, and machine for producing goods and services desired by the society to satisfy the wants of the people. And what is the objective of production planning? The ultimate objective of production planning and control, like that of all other manufacturing controls, is to contribute to the profit of the enterprise. This is the ultimate goal of any enterprise or any organization, to increase or to maximize the profits. And that can be achieved with maximum outputs as well as minimum inputs. If that can be satisfied, that ratio can be satisfied, then ultimately profit of the enterprise or profit of an organization will increase. It further says that as with inventory management and control, this is accomplished by keeping the customers satisfied with meeting of the delivery schedules. So profit can be increased with inventory management. Inventory is one of the most important part where nearly 30% of the finance is utilized. So if you can control the inventory management and if you can control the delivery to the customer, means customer remains satisfied and you can have a tight leash over inventory control, then ultimately it will be, you will be able to get more benefits from the inputs, and you will be able to get the profit margin increased. Production planning and control is one of the most important factor in industrial area. What are the various functions which are associated with production planning and control? Generally, there are four basic phases of control of manufacture, which can be which can be said that they comes under the umbrella of production planning and control. The functions are process planning. What is the process which you are going to use? The process planning is the first function which comes under PPC. It is the determination of where each operation on component, part, assembly, or sub-assembly is to be performed, which results in the route for the movement of a manufacturing lot through the factory. You have to, in the process planning, you must have the ability to select the proper process. Suppose, for an example, if you want to finish a product, so you must be able to, suppose you want to finish a product, you want to make a keyway on a shaft. So which part, which machine, which process has to be selected is of utmost importance. The keyway can be manufactured on a planer, on a shaper. It can be manufactured on a milling machine also. So out of these three, which process you are going to select, that will be the most important part. So, and what will be the route through which that particular material will be directed for ultimately completing the process on it. So these are one of the most important, this is one of the most important thing, that selecting a particular process, one of the most important function of PPC. Then second point or second function which comes under production planning and control is loading. Once the route has been established, the work required can be loaded against the selected machine or workstation. The total time required to perform the operation is computed by multiplying the unit operation times given on the standard process sheet by the number of parts to be processed. This total time is then added to the work already planned for the workstation. Means, what will be the time limit of a particular part on a particular machine which you have selected? It is what is the loading, how much time in the, suppose the 8-hour shift is there. If you are performing an operation on a particular machine, then how much time will be required to finish that operation on that particular machine? So that machine will be loaded for that particular amount of time. So you have to perform this function, and how many parts will be finished through those machines, that will have to be taken into account, and that will give you the ultimate percentage or ultimate amount of time for loading of that particular machine. Similarly, third function is scheduling. Scheduling is the last step of planning function. It determines when an operation is to be performed and work is to be completed. The difference lies in the detail of the scheduling procedure. Similarly, another function is combining functions. While it is easy to define where as process planning and how much work as loading and when as scheduling, in actual operations, these three functions are often combined and performed concurrently or simultaneously. So it is nothing but combination of the above three set factors. Another important function associated with PPC is dispatching. That is authorizing the start of an operation on the shop floor. That is known as dispatching. Dispatching the parts, the raw material, the tools, the mains. That is nothing but you are authorizing the starting of that particular production process. This dispatching function may be centralized or it may be decentralized depending upon the size of the organization. Another function is reporting or follow-up. The manufacturing activity of a plant can be said to be in control when the actual performance is within the specified limit or as planned. And if the tasks are started and completed on schedule, there is no concern. Optimum operation of the plant, however, is attained only if the original plant has been carefully prepared to fully utilize the manufacturing facilities. Means Utilization of all the available resources is must be at the optimum level. If that can be achieved, then it can be said that your manufacturing activity is in very good condition, and if it is working as per the planning, then it can be also said that it is in control. Corrective actions and replanning are some other functions. Corrective action is the keystone of any production planning and control activity. Here, one point must be remembered that a plant in which all manufacturing activity run on schedule, in all probability, then it can be said that it is not being scheduled to its optimum productive capacity. Why? Because with an optimum schedule, manufacturing delays are the rule, not an exception. This must be kept in mind. Replanning. Replanning is not a corrective action. It revises routes, loads, and schedules, and a new plan is developed then. This is generally required in manufacturing process. Why? Because of changes in marketing conditions, changes in taste of the customer, changes in manufacturing methods, or introduction of new technology, or many other factors affecting the plant often indicate that a new manufacturing plan is needed. So, hence, replanning is also one of the important part of the PPC. Now, production planning and control system, it plays an emphasis on the control of work in process. The system will in effect tie together all previous records and forms developed in all planning for the manufacturing of the product. And PPC is totally associated with market forecast and sales order. Its value of production planning and control is that it will indicate future trends in demand for manufactured product, that is market forecast. Work shift policies, plans for an increase or decrease in manufacturing activity, or possible plant expansion. That totally depends upon the market forecast feedback which the company gets. Sales order is also one of the important part where PPC will come in, where customers order specified orders on the quality and the shipment dates will be taken into account. Another class related with PPC is shop order. It deals with the manufacture of component parts. Shop order. Standard process sheet is there, engineering specifications is there, route sheets are there. These all are part and parcel of the PPC. Loading charts. The load charts are prepared to show the productive capacity. Similarly, here, engineering specifications are nothing but the blueprints and bills of materials that are used by the production planning and control. Job tickets is there, project planning methods is there. Now we come to another point. What is a production system? Production system is nothing but it can be defined as the combination of human resources, equipment, factory layout, and procedures organized to accomplish the manufacturing operation of company. So production planning will be there when there will be a production system. And what is a production system? Production system consists of two parts, that is facility and manufacturing support system. Another point to remember is that the production system can be categorized into four parts. Number one is continuous flow type production system. Number two is mass production system. Number three is batch production system. And number four is job production system. You must have been aware of this. This is a graph which shows where this system lies. This is the production or operations volume, and this is the product or output variety. So for the continuous flow type, the variety is very less. There is no variation, but the volume of production will be of the highest order. In mass production system, a little bit variation can be adjusted in the output, and the volume of production will be high but less than the continuous time. Similarly, in batch type of production, the variety in the output of the product can be of a significance importance, but the volume of output will be less as compared to continuous flow type of production and mass production type. Similarly, in job shop production, the variety of the product is of the highest order, whereas the production rate or the volume of production is of the lowest, in the lowest range. So from this you can say that the operation flexibility goes on decreasing, and production operation capacity goes on increasing from left to right and right to left. That is, production operations flexibility will be more when you go towards the job shop type of production, and the production operation flexibility will be less as you comes towards the continuous flow type. Similarly, when the production capacity of the job shop will be less, and it will be highest order on the continuous flow type of production. Now, what is a continuous flow type of production system? The example of continuous flow type of production systems are chemical plants, oil refineries, where continuous processing of the chemicals and the oils are being done on a three shift basis, or the production is completely going on through the various machines involved there. That is a continuous flow type of production system. Similarly, in mass production system, the components are produced in very large quantity, and again the variety of the component is very minimal, as we have seen in the previous slide. And the mass production system uses a product type of layout, and various examples of mass production systems are manufacturing of nuts, bolts, springs. These are produced in very large quantities, and you cannot vary the variety of the product. Only a little bit adjustments with respect to some size or some shape will be available, but you cannot change the actual variety or actual product with much more specifications. That is the mass production system. In batch production system, the components are produced in medium quantity and medium variety range. Means you can change the variety a little bit, but the quantity of the production will be medium. The example of batch production systems are manufacturing of marine engines, vehicles, clothes. Generally, nowadays, the batch production system is utilizing flexible manufacturing system. What is an FMS? We will try to understand this FMS in when we will go or switch over to the CIM. Last system is the job production system. In job production system, the components are produced in low quantities based on order. And in job shop production, the minimum lot size can be 1 unit. Suppose manufacturing of a ship, manufacturing of aircraft, these are on a very limited basis. So the production system applied over here is job shop production system. These are the some of the points which we are associated with production systems and production planning and control. Now we switch over to another topic, that is forecasting. Why forecasting is needed? Since the growing competition, frequent changes in customers' demand, and the trend towards automation demand is increasing continuously. So which product will be more sought by the customer? What will be his or her expectation from a product goes on changing. There were more time and then should be given to the future than to the past, because the future is a huge possibility as compared to the past, and what is likely to happen, that is of utmost important from the point of view of a manufacturing unit. Why? Because whatever we are manufacturing in an enterprise, that should be accepted by the customer, and customer should buy it. That is the main focus of any organization. So, and that can be achieved only when the organization and the enterprise is directly associated with the customer's demand and are living in the happening world, and that can be achieved with the help of forecasting. So future, what is likely to happen, is more important than what has happened. So, and what is likely to happen will be available to you through only forecasting. So when estimates of future conditions are made on a systematic basis, that process is known as forecasting. When you are estimating the future condition with a systematic basis, that is forecasting, and that is totally different from prediction. Prediction does not have any systematic basis for estimating the future conditions. The process of this systematic estimates of future condition is called forecasting, and the figure or statement thus obtained is defined as the forecast. The following are the main functions of forecasting. Number one, the creation of plans of action. What type of plan you want for taking into consideration for predicting the future in a planned manner, that is forecasting. The general use of forecasting is to be found in monitoring the continuing process of plans based on forecast, and the forecast provides a warning system of the critical factors to be monitored regularly because they might drastically affect the performance of the plan. Now, what are the various fundamentals of forecasting? A prediction, projection, or estimate of some future activity, event, or occurrence is forecasting, but it should be on a systematic plan basis. Then and only then the prediction, projection, or estimation or for future activity or event or occurrence will be known as a forecast. It must employ a systematic method or systematic base for predicting the future. Now, types of forecast, there are different types of forecast. Number one is economic forecast, technological forecast, and demand forecast. The economic forecast predict a variety of economic indicators like money supply, inflation rates, interest rates. They depend money economic forecast on, these are generally the policies determined by the government. uh, what will be the inflation rate, what will be the interest rates. Based on interest rate and the demand and supply and purchasing power, inflation rates will be there, that can be calculated. So that can be calculated for the present scenario, and based on the present scenario and the past scenario and looking into the future, economic forecast can be done. Similarly, technological forecast also plays also a very important role. It predicts rates of technological progress and innovation. For this, the prediction method or the systematic analysis will be of different type from the economic forecast methodology. So here in technological forecast, a different set of rules will be employed to arrive at a particular forecast related with technology. The third one is the demand forecast, which predicts the future demand for a company's products or services. Since virtually all operation management decision, both in the strategic category as well as the tactical category, requires as input a good estimate of future demand, this is the type of forecasting that is emphasized in our lecture. Types of forecasting methods. What are the various types of forecasting methods? One is the qualitative method, another one is the quantitative method. Qualitative method is, these types of forecasting methods are based on judgments, opinions, even intuitions, emotions, or some personal experience, and are subjective in nature. They do not rely on any rigorous mathematical computation. This is a qualitative method. They employ certain bases, they employ certain methodologies, and based on those methodology, some opinions are made, some judgments are taken, and some on personal experiences, you can then forecast or predict the future. Similarly, another type of forecasting method is quantitative methods. These types of forecasting methods are based on mathematical models and are objective in nature. Instead of subjective, they are objective in nature. They rely heavily on the mathematical computations, that is qualitative mathematics and quantitative mathematics difference. What is the qualitative forecast methods? The qualitative forecast methods are various methods are there. I have only listed here 4 important methods. One is the executive opinion. Executive opinion is an approach in which a group of managers meet and collectively develop a forecast that is being done based on their particular experience and their knowledge about that particular component, about the company, and they sit across the table, and after discussing they comes to a conclusion. Similarly, market survey is an approach that uses interviews and surveys to judge preference of customers and to assess the demand. Here market survey form is distributed to the customer, then customer sends the feedback to the company after purchasing or even without purchasing that company's product, and those market surveys or the feedbacks given by the customers, then they are analyzed, and then they, after analysis, they are judged with their components the company is producing, and whatever the new ideas has been given or the new preferences which the customer wants has been analyzed, then they are tried to be incorporated into the component of the product of the company, and that depends upon the uh, survey done by the company from the customers, and based on those market survey, then the demand for future is forecasted. Another method of qualitative method is forecasting is sales for force composite. Here salespersons plays very important role. Based on their experience, the salespersons, they estimate the sales in their region, and that is one of the most important, and that depends upon their intuition, their personal approach with the customer and the sellers. So again, this one is in subjective nature, and it is totally depends upon the salesperson's own experience and his or her own relationship with the customers and the sellers. Another method of qualitative analysis is Delphi method. Various experts, they sit over and then they discuss about the future prospects of the product or the component or of the services, and they discuss it very rigorously, and after their rigorous analysis, they comes to a conclusion. Here the personal leaning of the experts, the experience, their grip over the market forces, their knowledge about the various government policies, and their knowledge about the money in the future. So based on those subjective analysis, they arrive at a particular consensus for predicting the future on a limited basis, and that is nothing but the Delphi method of analysis. Quantitative methods, that can be divided broadly into two class: time series models and associative models. Time series models looks at the past pattern of data, and based on that they try to predict the future through some mathematical formula. And the associative methods or causal methods assume that the variable being forecasted is related to other variable in the environment. So some of the points or some of the methods or models of time series are naive method. This uses last period's actual value as a forecast. Whatever the last forecast value of sale is there, that is now will be the forecasted value for the future. That is a naive method. Simple mean average method. Here, all past data for a particular period is taken into account, and the average value is found out, and that average value based on the past data is the forecast for the next season or next period. Another one is the simple moving average method. Here it uses an average of a specified number of the most recent observation, with each observation receiving the same emphasis, that is the weight. Weightage is given to all the data on the same basis. Where is weighted moving average? Here different weightages is given to different values. Uh, Here the recent observations are of most importance than the previous one. Exponential smoothing is also one of the method to find out the to go for forecasting. Here exponential smoothing methods are used. Trend projection, here least square method to fit a straight line to the data, that is used for finding out the trend as well as for predicting the future or forecasting the future. Seasonal index is also one of the most important time series model, where depending upon seasonal patterns the data is collected and analyzed. Just like raincoats, that is not a product for the entire year, but it is a seasonal product. So seasonal indexes will be selling of an umbrella, similarly selling of sweaters. What will be the demand for the sweaters? That can be analyzed through seasonal indexes. That is some of the points in the forecasting methods. Error, since it is having some mathematical modeling, it is either subjective or it is analytical, objective type of forecasting. Error will be there in forecasting, and is nothing but the numeric difference in the forecasted demand and an actual demand. That is the simplest definition for an error in forecasting. Mean absolute deviation and bias are two measures that are also used to assess the accuracy of the forecasted demand. It may be noted that mean absolute deviation, it expresses the magnitude but not the direction of the error. That must be taken into account. Here our second topic ends, that is forecasting. And I hope you must have understood till now what is production system, what is production planning and control, and what is forecasting. Now we switch over to another topic, that is automation, because we want to learn the basis of computer integrated manufacturing, and computer integrated manufacturing cannot be understood without understanding the automation and without understanding the various systems which are associated with automation. So first we will try to understand what is an automation. Automation is the technology by which a process or procedure is accomplished without human assistance. It is implemented using a program of instructions combined with a control system that executes the instruction. Means here involvement of human operator is there just on a supervisory level, we may say. It is not the humans who are using their energy to run a process or a procedure to accomplish. Here everything is being done with a control system, and some program of instructions are provided to the control system, who ultimately executes the process for the final products. To automate a process, power is required. Why? To drive the process itself, and second, to operate the program and control system. Although automation can be applied in a wide variety of areas, it is mostly associated with manufacturing industries. Another point to be remember, that automation is a technology which is concerned with the application of mechanical, electronic, and computer based systems to operate and control production. This is the simplest definition which has been given by the Michael Grover. What that automation is a technology concerned with the application of mechanical, electronic, and computer based system to operate and control production. Some example of automation of process and production systems are numerically controlled and computer numerical control machines, automatic assembly lines, industrial robots, automated storage system like ASRS, automated storage and retrieval system. Similarly, computer aided production planning and control. So NC and CNC machines are there where you are using suppose you are using a CNC lathe. CNC lathe is nothing, but it is a lathe machine. Instead of a worker working over it for completing a job, the CNC is controlled through a control system, control mechanism to give you the final product. So instead of a human operator controlling the movement of the machines, those are being controlled by a controlled machine control unit, MCU, and the MCU is you require to feed the program of instructions to the MCU to control the movement of the CNC machine tool. Similar is case with the automatic assembly machines. Industrial robots are there for performing various operations. They can be used for some process controls like welding, spot welding, painting, or they can be used for drilling the holes. Even they are also used for moving the material from one place to another. That is for material handling purpose also they are used. Similar is the case with automated storage system. Here in automated storage system, you must also have this idea that it is having ASRS and AGVS, automated guided vehicle system. They both play a crucial role in material handling in the automated area. Another thing is computer aided production planning and control. We have seen production planning and control, various functions which are associated with, and those functions can be used with computer aided production planning and control. That may be computer aided production planning may be of a generative type, and it may be of a generic type. So they variable type that can give you the best results. An automated system consists of three basic elements. Number one, power. Number two, a program of instructions. And number three, machine control unit or a control system. So these are three main parts of an automated system. Number one, power, program of instruction, and a control system. Now, automation technology includes automatic machine tools to process parts or assembly machines, industrial robots. As I have seen, they also there for automatic inspection system and quality control like CMM, coordinate measuring machines, like machine vision, where you can inspect the parts with the help of automatic machines. So these are there. There are much more laser inspections are there, which helps in maintaining the specification within the required range. Now, what are the various reasons for automating? Number one is increased productivity, that is higher production rates, that is output per hour increases with the implementation of the automation with respect to manual operations. So ultimately productivity increases, that is if input remains same, output increases, and that happens because of one of the reason is also there. If the input remains same and output is increasing, that can be done by achieving the manufacturing activity within the specified range. If the or in other simple words, because of automation, scrap rate generation reduces considerably. So when scrap generation will be less, ultimately acceptable products will be more. So with the same input, the maximum output will be available, and that is nothing but it will be increasing the productivity. Second reason for automating was particularly in European countries or the American countries was the high cost of labor. That's because they moved swiftly towards automation since the last 70 years. And third point is labor shortage. Labor shortage is also a reason for automating a process. Why? Because the laborers are moving towards the service sector. They are not going towards the manufacturing sector. Fifth point or fifth reason for automating any particular process is safety. Automating the operation and transferring the operator from an active participant to a supervisory role keeps him in a safe condition. That's why the reason for automating is safety of a worker. Another point for implementing the automation in an enterprise is high cost of raw material. So the raw material comes nowadays comes in is taking more economically of a high cost. So companies want that there should be no scrap generation. So when they want that whatever raw material they are purchasing, that must be converted into acceptable products, and that can be achieved only through automation. That is the main thinking behind this implementation of automation. Because as the scrap generation is less, the benefits in terms of acceptable parts will be more, and ultimately it will increase the profit rate. Another important point is improve product quality. Automation not only produce parts at faster rates, but it produce with greater consistency and conformity to a already acceptable specification. And another important point is that it reduces the lead manufacturing lead time. MLT is reduced considerably, while any enterprise or any company or any organization switches over to automation. Need for automation and advantages of automation are the same. Number one, to increase the productivity, to reduce cost of production, and that cost of production can be reduced by reduction in labor cost and reduction in scrap or rework. Because of that, the cost of the raw material will be directly converted into acceptable parts. So that's why the need the reduced cost of production, to improve product quality, to reduce production time. That's why MLT is reduced, to improve working safety and to have better control over manufacturing activity. And these are the same points can be termed as these are need for automation and these are the advantages of automation. What are the limitations of automation? Very high initial cost. At the very first level, you have to invest on a high level for switching over to automation, because automation is concerned with mechanical, electronic, and computer based technology. Similarly, the cost of maintenance of these automated machines are on a higher side. And to operate these automated machines, semi skilled laborers cannot be used. They require these automations machines require high skilled labor. Now here in this slide we can have a look at a comparison between fixed and flexible automation. Other than fixed and flexible automation, there is programmable automation is there. In fixed automation, the purpose is specific, or in simple words, the product is fixed. Only variety changes is not acceptable in fixed automation up to a certain extent. Whereas in flexible automation, any type of product can be manufactured with a little bit changeover on the automation machines. Where on fixed automation, you can make little bit changes in specification, but you cannot make the variety different variety products on a or components on a fixed automation. So in fixed automation, purpose is specific, whereas in flexible automation, the purpose or product is variable. Ease of making changes and upgradation. It is very difficult in fixed automation, whereas it is easy in flexible automation. Whereas maintenance is hard in fixed automation, it requires much more concentration, much more special machines, much more type of skilled labors. Whereas in flexible automation, it is easy because there are some standalone machines are also there. So it becomes very easy, and the machines in flexible automation are of general type, so they require general type of maintenance. Capability depends upon on manufacturing and design for fixed automation, where flexible automation it is very high. Speed in fixed automation is slow, in flexible automation is fast. Economic efficiency, you can say it is suitable for a small system, it is suitable for all types of system. Another point to understand when we switch over to CIM is group technology. Just a little bit information I want to share you with respect to group technology, that it is a manufacturing philosophy in which similar parts are identified and grouped together to take advantage of their similarities either in design or in production. So that is group technology, where different types of parts are grouped together on the basis of either design or their production process. Similar parts then are arranged into part families where each part family possesses similar design or manufacturing characteristic. GT offers substantial benefits. The first benefit is that it promotes standardization of tooling, fixtures and setup. Material handling reduces because within a machine cell can be created for a particular part family, and that machine itself will help in uh, producing or machining that particular parts. Hence material handling reduces considerably. Process planning and production scheduling also gets simplified. Work in process WIP is reduced. Worker satisfaction generally improves with the GT cell, and high quality of work is accomplished using group technology because in a machine cell only those parts which belong to a same family they will be processed. So a particular worker then will become an expert in handling those particular part family production systems. This is a simple example where the for the turning machine, milling machine, drilling machine, these are for part 1 family, these are for part 2 family, shaper, drill and grinding machine. So part 1 family, the families then which are grouped together on the basis of a same design. Suppose a shaft is there, and similarly with respect to shaft, a block is also there of suppose a square block is there. So those can be turned on a simple turning machine, lathe machine. Suppose a shaft of a circular diameter can be turned on a simple turning machine. Hence a square block can be turned on a turning machine, but here you will require a 4-jaw chuck for turning that square block on a turning lathe machine. So the part families will be able to go through a special set of cell of a simple machine on which those parts or components belonging to the same part family will be processed. They may be either processed on all the 3 machines, or they may be processed on either a single machine as required by the specification or the output design. So they not have to move from one place to another or all over the workshop floor, but they will have to follow a simple path, and that's why the material handling gets reduced. Another part family is, suppose here, shaping, drilling and grinding. So those parts which needs only shaping, drill or grinding or any one of these 3 machines, that will be routed through this particular this particular setup of machine or machine cell. So here it is very much easy to accomplish the part according to the or accomplish the design accord. हाँ, मैं क्लास ले रहा अभी. A part family is a collection of parts that are similar either because of geometric shape and size or because similar processing steps are required in their manufacture. That is, I have already discussed it with you. Now, introduction to SIM. SIM is the architecture for integrating the engineering, marketing, and manufacturing functions through information. Functions through information technologies. In the broad sense, SIM involves the integration of all the business processes from supplier to end consumer. Our computer integrated manufacturing includes all of the engineering functions of computer aided design, computer aided manufacturing, and not only it requires computer aided design and computer aided manufacturing. सर मैं क्लास ले रहा अभी. हाँ. It not only requires computer aided design and computer aided manufacturing, but it also includes business functions that are related to the manufacturing. When all these 3 points, computer aided design, computer aided manufacturing, and the business functions of the firm that are comes under one umbrella, then that is known as computer integrated manufacturing. And when you are using computer aided manufacturing and computer aided design only, that is you have used the information technology only on the shop floor, that designing is being done through computers, manufacturing is done through automatic machines, material is being handled through AGVS, and material is being used to is being stored through automated storage and retrieval system. Inspection is being done through CMM and machine vision. Then but it is information technology is only on the shop floor, then that system is flexible manufacturing system. But when in flexible manufacturing system, when you are incorporating business functions with it also, then it becomes your computer integrated manufacturing system, that is SIM. The ideal SIM system applies computer and communication technology to all the operational functions and information processing functions in manufacturing, from order received through design and production to product shipment. This is a scope of a CAD CAM and SIM. Scope of SIM is this ring, complete ring. It covers design, manufacturing planning, manufacturing control, and business function. All these are nothing but the part and parcel of SIM. Design, manufacturing planning, and manufacturing control, these are part of the CAD CAM system, that is FMS system. But as soon as you include business function into design, manufacturing, and manufacturing control, that is in CAD CAM, as you include business function, then that becomes the scope of the SIM. Now a little bit further, computerized elements of a SIM system are computer aided design, means that are being done for geometric modeling, engineering analysis. You are using different types of softwares can be used over there, design review and evaluation, and automated drafting. For this this is the purpose of the design, where you are using computers for designing through these particular mediums. So design is computerized completely. Even for printing the drafts, you are using the computer and printer. Similarly, for computer aided manufacturing, cost estimation is being done through computers or computer softwares. Computer aided process planning, variant type of method is there, generic type of method is there, it is being done through computers. Numerical control part programming there, APT programming is there, which are which can be accomplished for manufacturing. And similarly, MRP is there, material requirement planning, capacity planning. These all helps through computers. So computer aided manufacturing is second point. And manufacturing control, process monitoring, shop floor control, computer aided inspections by CMM and by machine vision and laser inspection and other types of inspection. These all are nothing but FMS. And as soon as you add business functions, that is computerized business system, order entry, whatever order has been received, accounting, what are the various functions of the company where uh, economic activity is taking place, how much amount is being utilized by which particular system and design. Everything is related with business function is on the computer. Then order entry, accounting, payroll, customer billing, and they all these can be attached through a single network, and that can be available to the management at the fingertips. That is known as your complete CIM system. Here you can understand where engineering designs, manufacturing planning, manufacturing control, and factory automation are there, and which can be, which is nothing but your complete set under the computer integrated manufacturing. This design done through computer analysis and simulation, documentation, process, quality control, scheduling, material flow, then assembly, inspection, material process, everything is being done in the through the computer. The Computer and Automated System Association of the Society of Manufacturing Engineers defines SIM as the integration of total manufacturing enterprise by using integrated system and data communication coupled with new managerial philosophies that improve organizational and personal efficiency. SIM is recognized as islands of automation because we have just discussed CAD, CAM, computer engineering, group technology, then manufacturing planning and control, factory automation, business management, all is done through the computers and which are available to on a network and which are available to the management or other person. SIM hardware and software. SIM hardware comprise manufacturing equipment such as CNC machines or computerized work centers, robot work cells, DNCs, that is the direct numerical control machines, FMS systems, work handling and tool handling devices. For work handling, you are having AGVS. For tool handling, you are having turrets, automatic turrets, uh, automatic ATMs are there, tool handling systems are there. So they comes under the SIM hardware. CNC machine, CNC lathe is there, so you can use the CNC lathes. Uh, Work handling devices are there. Robot is one of the work handling device. Similarly, for moving material from one machine center to another machine center, you are using AGVS. And for suppose for tool handling device on a turret, there are turrets, automatic turrets are there, where you can put the tools or screw the tools and you can use those tools as per requirement. Storage devices are there, automatic storage device, ASRS is one of the system. Sensors are there, shop floor data collection devices are there, inspection machines are there like CMM and machine visions. These comes under the SIM hardware. Machines, manufacturing equipment. Second thing which comes under SIM hardware are computers, control cards, CAD CAM systems, data entry terminals, barcode, RFID tags, printers, plotters, and other peripherals such as RS-232 cable, modems, connectors. These comes under the hardware system. They are broadly classified as equipment and computers. The software, SIM software comprises computer programs, and these computer programs are used to carry various functions like in management information system, sales, marketing, finance, database management, modeling, design, analysis, simulation, communication, job tracking, where the job is there now, right now, in which position is the job, that can be tracked through these computer softwares, shop floor data collection system is there, order entry is there, material handling, drivers, process planning, manufacturing planning, workflow automation. Means there is a huge amount of data is there, and which is available at the fingertips to the management or to the analyzer, from where they can use those information or use that information for arriving at a particular point and taking the right decision at the right time to cor- uh, correct or to correct the wrongs if any, or to nullify the losses if any, so that in future, in near future, very near future, corrective actions can be taken at a very small amount of time, and thereby reduces the scrap generation or rework generation. Nine major elements of a sim system are shown here, and we have already discussed it. Once again, we will try to understand that what are the major elements of a sim system. One is marketing, product design, planning, purchase. Even purchasing activity is also done through the computer system, and it is and the record is kept there, available at the fingertips. Manufacturing engineering means what will be the tolerances, what will be the various scheduling activity, what will be the job route. Everything is being done through the computer. Factory automation hardware, that is the CNC machines, warehousing, ASRS, logistic and supply chain management. It is also one of the most emerging area, and one of the most upbeat area in coming future, that is logistic and supply chain management. Finance and information management, all these are some of the major elements of a sim system. And why this sim is being used? Because the most important part a manufacturing engineer has to play, or the most important objective which he has to follow, is to be a successful in this competitive global context, and that can be achieved with the reduction in inventory, with the lower cost of production, reduced waste or reduced rate of scrap, and improved quality. And that can be achieved, if you permit me, with the help of Six Sigma. So even the if you look at the bell shaped curve, then the bell shaped curve must be nearer to the mean. If that happens, then the manufacturer engineer will be able to follow his or her objectives, and that can be achieved with the help of computer integrated manufacturing. Another point is increased flexibility in manufacturing can be achieved immediately and with rapid response. That a new product change is there, that can be used with giving the new programs. The CNC machines will be reading the new programs and generating the new production changes there. Amount of parts to be produced can be increased or decreased. Processes can be changed there. Equipment change can be done very rapidly and in response to the customer's need. Change of the personnel can be achieved with the help of sim technology will be able to meet these challenges with the minimum amount of time required. Now the last points are there, that the evaluation of computer integrated manufacturing, it is started with the MIT in 1952. Earlier they used numerical control machines. Basically they were all hardwired systems, and in the NC machines, paper tape were used as an input medium for giving the information or for providing the uh, job description to the controller. The tape reader transfer the program, written program on the tape, to the memory of the machine tool, but it used to deliver the program block by block. Then mainframe computers were used, and they come into on the scene in the 60s. And by mainframe computers, direct numerical control was established, and through direct numerical controls, number of NC machines were attached to the mainframes, and mainframe used to provide block by block program, or block by block program to the memory of the different CNC machines attached to the mainframe through DNC. After the advent of mini computers, then sole numerical control machines were commonly used. Instead of then paper tape, the program was directly written on the computer, and directly through the computer and RS-232 cable, it was fed directly to the computer control, to the machine control unit, where the machine control unit will be analyzing it, and after processing will be sending the signal to the mechanical part of the machine. And this development of mini computers led to the development of computerized numerically controlled, or CNC. Subsystems of CM, we have gone through it: computer aided design, computer aided engineering, computer aided manufacturing, and computer aided process planning. Other than that, computer aided quality assurance is it is also there in the SIM: production planning and control, and enterprise resource planning. These are some of the points which are there in the computer integrated manufacturing, and that must be taken into account. These are some of the points which I have discussed, and hope you must have understood various points associated with this. That is, what is production system, what are the production planning, what is forecasting, what is SIM, and what is automation, and what is SIM. I hope you must have enjoyed it. Thanks a lot for attending the program, and thank you very much.